Welcome to the long-awaited talk, Is the Zephyr device tree too complicated? I'm Tim Guite from Magpie Embedded. So I wanted to start off with a quick poll. Can you please raise your hand if you think the Zephyr device tree is too complicated? Cool. I'm going to call that maybe 40-50%. So if you are of that opinion, you're not alone. You know, the Zephyr community is quite wide-ranging. And I think it's important to recognize that, basically. So, yeah, if you thought no, it's Betteridge's law of headlines says if you ever ask a question, yes, no question in a headline, the answer is always no. To skip right to the end, my answer is maybe for a lot of users. And actually, when I started writing this presentation, looking into it, I thought that was more the case, and since then, you know, even in the last few weeks and days, there have been updates to actually tools to help us with this, which I'm gonna talk through. So yeah, initially this was going to be kind of 50% background, you can read kind of complaining, and 50%, you know, my thoughts and proposals for how we can make it better, and it's now got kind of 40% fixes and tools and updates in there. So this is kind of my journey through Zephyr a little bit in the background, and I think this is quite common. You know, you go to the Getting Started page, it's quite a gentle stroll in the park, right? Everything works, you know, you download it, you get it set up, you build for your board, you flash it, it's blinking, like that's all great. And then, you know, maybe you try and do something a little bit more complicated. You go to the sensor driver, you try and change the sensor, you try and take two samples and put them together, you know, combine them. And it kind of feels like you're met with a bit of a cliff. You've got these core concepts, Kconfig, device tree. If you haven't ever heard of them before, you know, there's a lot to learn there. And then all of these details around what's a node, where's the driver code, where do I just put the I2C address? Like that's all I want to do is just get it working, get some basic comms going, you know, to my chip. And this can seem a little bit overwhelming. So I did a really good Zephyr training a few years ago, and the person presenting said this will make a lot of sense if you have kernel development experience. I think that's probably true, but I think one of the reasons why Zephyr's been so successful is because it's brought such a wide range of developers into the community. I mean, I'm just ballparking, but it's got to be less than 1% of software developers in the world, right, have actually been doing kind of kernel development, any kind of contribution, even embedded Linux work. And so that's good for them. You know, if you have this kind of background and you come to it, that's a leg up. But are there ways where we can make this more accessible for everybody else? So what is device tree for? It's a hierarchical data structure that describes hardware. It basically gives us a framework for specifying the hardware on our systems. Like a lot of things in Zephyr, these are things which, if you didn't use them, you would be doing anyway. You just would be kind of doing your own version of it. It's quite flexible and powerful for people who understand it well, but I do think it's confusing for people who are new to the ecosystem or developers who just want to set up chains of I2C and SPI devices, which is all already supported in Zephyr. You just want to tell it, you know, which ones you have and where they're going. And again, I don't know if we have stats on this, but that's probably more people than are doing the maintenance and kind of upstreaming driver code. And ultimately, that's what's going to give us our actual applications at the end of the day. So could we make it easier for that use case? Yeah, the device tree spec is not that long. It doesn't have that much detail in it. But it does kind of give you, you know, a little bit of detail. Like I said, if you go through to the sensor samples, you know, in my opinion, just if you come at this as a beginner, one of my bugbears is you know, you've got @68, you have to put the unit address in there and then just repeat it in reg, right, for an I2C device. Seems redundant to me. You know, some of the samples are still quite device specific. I think that's kind of a legacy thing. There's sort of conventions around how to do them, what's the right way to do them, which are not immediately clear. It's quite hard to follow through to the driver code. I was going to show you on my laptop, but I can't do that now. You know, if you search for Bosch BMI 270 or whatever, it's going to bring you to the bindings file, which is YAML file, but it's not source code. So if you're just trying to figure out, well, what bytes are getting sent across, you then have to go and search for something else, or no, you need to put in underscores or whatever. And yeah, again, some of these samples are using some of the node labels directly. I feel like Blinky is, uses the alias. It's quite well abstracted. Not all of them are like that. And I think for a beginner who's coming to Zephyr, they'll just think, why do I have to do all of this? Like, what's going on? If I just was writing my own code, it would be really simple for me to just write, a class that wraps kind of an I2C device that has an address and a label or something like that. So is there an easier way? Could we come up with some sort of simple definition for I2C and SPI devices? Could we pull in that info from the bindings, give us much faster feedback while we're writing the device tree as to whether or not it's going to work? Could we come up with ways to make it easier to abstract them, to split it into kind of multiple DTS files, which is what we need to end up doing, and use those DTS files as the backbone, essentially, of the system? This might reduce some of the flexibility. Obviously, adding tools always adds complexity, and there might be some kind of issues between device tree and Kconfig, but I think it's worth thinking about. So, some of the updates is, as of 4.2, the Zephyr.dts file gives you a lot of information now about where the settings have actually come from. So this is in the build folder. If you go through and find that, it gives you a comment, and it'll tell you exactly where that value was set. So that's really good. There's Kyle from Nordic Semiconductor has been developing a language server protocol, which gives us like syntax highlighting, allows you to click through and follow through nodes, helps you get things from the source and track back to where they came from, and gives you some autocomplete and things like that, which I think is a massive step forward in terms of making it easier to just operate and look at the device tree and understand what's going on. He does have a PR open, which again, I was going to show you. It's got well over 1,000 files changed because he's trying to format every single device tree file with a format that he's written, which I think, you kind of have to respect someone who's going to put in 1,000 file change as a PR. And Nordic also have a graphical viewer for the device tree. And there's a tool called DTSH, which gives you a shell-like way to view your generated device tree file. So again, you can navigate around it a little bit and see what's going on. So I think all of these tools have come in quite recently. There clearly is demand for them. And I think that they're things which we can probably highlight, once you, in that kind of beyond the getting started stage, and trying to use Zephyr for building these applications for people who don't have a device tree background. And to be honest, even if you do, I think you'll find a lot of these tools really useful. So I'm still raising a question, which is, could it be even easier? Things like abstract device trees, or separating out some of these layers, right, so that they're not specific to boards. There have been some good presentations at this conference about building real applications and having multiple revisions, for example, of the device tree, or having it work for boards and for the native simulator, which we want to work. I think it'd be good if we can get more connection between like the source code that we're writing and the information that's in the device tree. And there's a lot of information that's actually collected by these scripts, which are already in Zephyr, and they're used when you do West build to generate the final device tree. So I think that could potentially be reused, to maybe build some other tooling around this. And like I said, maybe have classes for working with these bindings more directly, letting you know what your options are for all of these different settings and what they kind of mean. So that's something I'll be looking at. I think it's, the infrastructure's already there, and I think there's a lot of potential to build better tools in the future. I've listed a bunch of resources here that I found useful on my journey, kind of understanding device tree, and obviously some of these tools going forward. And yeah, that's it. So thank you very much for coming. Is there not another talk like now? Or? Oh. Does anyone have any questions? Yes.
question is, like, you forget to mention that in Zephyr, for example, you have stuff like all of the DDSI files that Zephyr provides. Like many of those files are actually have a preprocessing step. They use like C preprocessing, like includes with the definition in C files, and like one of the flaws of device tree, for example, if we have like pin configuration, device tree contains only the selected values. If I need to like change, like I'm building my custom board and I have like my own schematic, I will end up digging up the data sheet with all of the table for all of those values for pin multiplexing, because none of those are going to be reflected within the device trees, actually. And also, it's going to be like, you will have to jump from, because of the structure that Zephyr uses. You have like highly hierarchical structure, and you have to do like jumping from one DTSI to another DTSI.
Yeah,
so you end up with like 20 tabs open, and you have
no, I agree. Yeah.
cross-check, and there is unfortunately no tools that allow you to view these like as a whole, like consolidated. That makes life hard, basically.
Yeah. To wrap up for anyone who didn't hear, I don't think there was really a question. It was again more of a call for call for new tooling to help us work across these situations where there are multiple DTS or DTSI files required to bring a driver together. And I guess sometimes a situation where a driver hasn't been fully instantiated with respect to all of the possibilities in the data sheet, right? So there are some situations where maybe the driver just needs to be updated and have some contributions, which I think are always welcome. But if you're going to add some of these customizations on or kind of extend the driver to be able to pull all of that together. So I agree. Yeah, I think that's an example of the kind of tooling we could do with. Yeah.
So I think there was also a talk regarding the Linux device tree 101. And I think the maintainers are also there. So device tree is not a Zephyr based
Right,
thing.
right,
It's used in U-boot, the bootloader. It's being used in Linux, of course, and now Zephyr. So any tool or anything, I think it should not be Zephyr oriented. There should be an industry-wide consensus how we can use it. I think maybe there are more people from the Linux world or bootloader world that can collaborate on this initiative like we do for the schema or for the specification.
Yeah.
So I would just say that let's do it at more of an industry-wide way rather than something Zephyr is specific, otherwise it won't help.
Yeah, sure. Yeah, so I was just highlighting device tree is not a Zephyr specific tool. It comes from embedded Linux background. There's some things that are slightly different in the way that Zephyr handles it, but the DTS spec, that device tree spec, is used across multiple projects, Linux probably being the largest. And yeah, for example, the language server protocol work that I was showing is extendable to any device tree. It just has configurations to set it up for Zephyr. And I agree, the more tooling that we can use across the device tree or across these different projects and have collaboration will probably be really good. This is maybe one where we can kind of push it from the Zephyr side and hopefully pull something back. I do feel like there's a lack of tooling available for this kind of device tree work across all of the projects at the moment, right? And it just makes it more difficult to use in Zephyr.
Worse in other projects too.